Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. A student has asked for help on this question 11 here, which comes from exercise 2F of the Cambridge Extension 2 textbook. So that's part of the proofs section of that textbook. And in Cambridge, proofs comes just after the first treatment of complex numbers. So as you'll see in this question, it's a little bit of proof and a little bit of complex numbers combined. So it's a three-part question. All three parts are linked. Part A says to let A, B, and C be the length of the sides of a triangle, and let the angle A be opposite the side A. We're told to use the cosine rule to help prove that the magnitude of B minus C is less than or equal to A, which is less than or equal to B plus C. So in other words, we're being asked to prove that one side of a triangle is longer than the difference between the other two sides and shorter than the sum of the other two sides. Part B then says, hence prove for any two complex numbers Z and W that the magnitude of mod Z minus mod W is less than or equal to mod Z plus or minus W, which is less than or equal to mod Z plus mod W. And then part C says, under what circumstances would this magnitude of mod Z minus mod W be equal to mod Z plus W? Alright, so kicking off with part A, I'll just write what we're being asked to show. So we want to show that this magnitude of B minus C, so the magnitude of the difference between two sides is less than or equal to the other side, which itself is less than or equal to the sum of those two sides. And maybe I'll just quickly draw a small triangle just to kind of visualize what that's dealing with. So let's just call it A, B, and C. And we're told that opposite angle A is the side A, which is typically how you'd label triangles anyway. Opposite angle B would be side B, and opposite angle C would be side C. Now we're told to use the cosine rule. The cosine rule, it's kind of an extension of Pythagoras' theorem for non-right angled triangles. And we can pick any side to be the focus. And in this case, because our inequality has A in the middle, I think it makes sense to choose A as the focus of the cosine rule. So we'll have A squared equals B squared plus C squared minus 2BC times cos A. That's how we can write out the cosine rule. Now, taking a look at this inequality, we can kind of see that we kind of want to get rid of these powers of 2. And a clean way to do that would be to take the square root of both sides, but I think before that, we kind of need to get a perfect square over here. And I think for this, if I start by focusing on this part of the inequality, then I'd like to have B plus C squared. So to do that, I'll go B squared, I'll just add twice the product, plus C squared. And if I'm going to add twice the product, I'll need to subtract it so that I haven't changed anything. And then we have our minus 2BC times cos A already there. So that I can write as B plus C squared minus 2BC, and then that will factor out to be 1 plus cos A. So I think we're looking good. It would be ideal if we can get rid of this part so that then we can take the square root of both sides. And I think here's where we can bring an inequality into it, because we can know that this whole component will be less than or equal to 0. And the way we can know that is we've got this negative out here multiplied by a whole bunch of things that we know are positive. So we know 2 is positive, the magnitude of 2. B and C are sides of a triangle, so they're positive naturally. And if we think about 1 plus cos of A, maybe I'll just draw up cos A over here just for reference. because what we'll see, hopefully you know, the cos curve oscillates between 1 and -1. So if I just call this A, this would be pi, 2 pi, 1, -1, and our cos curve kind of looks like this, kind of oscillating between, I mean, the main idea is that we're between 1 and -1 no matter how many times you repeat. So 1 plus -1 would be 0, 1 plus 1 would be 2, and then everything in between. So this bit here is between 0 and 2, which is positive, 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 so the whole thing must be negative. So what we can say is that a squared is some number minus something else. So therefore a squared must be less than or equal to b plus c squared. And that's since negative 2bc 1 plus cos a will be less than or equal to 0. So at this point we can take square root of both sides, so we get a less than or equal to the square root of b plus c squared. That by definition is the absolute value of b plus c. Now, as I mentioned, b and c, they're both lengths of a side of a triangle, so they're naturally positive. So if you take the absolute value of a positive number, you're effectively not doing anything to it. So you can kind of just write that as b plus c. So we've got a less than or equal to b plus c, and that corresponds to this part of the inequality. So now what we'll do is we'll take a look at this part of the inequality. And I think effectively we're just going to do the same thing, but instead of a b plus c squared, we'll go for a b minus c squared, so that we can effectively do the same thing and hopefully end up with this part of the inequality. So maybe there's probably enough room if I kind of say similarly, we can have, we'll have a squared equals, and instead of b squared plus 2bc, I'm going to say b squared minus 2bc plus c squared. Now if I'm going to minus 2bc, I'll then plus 2bc, and then we've got our minus 2bc cos a at the end. So that we can get to b minus c squared plus 2bc 1 minus cos a. And now if we think about this, 1 minus cos a will still be either 1 minus 1, which would be 0, or 1 minus -1, which would become 2. So this is still between 0 and 2. Positive, positive, positive. So now a squared must be greater than or equal to this, since it's this plus something. So a squared greater than or equal to b minus c squared. So a greater than or equal to the absolute value of b minus c. And because b and c, depending on how big they are relatively, this bit inside could be negative, so the absolute value needs to stay. So that's kind of where we leave that. But actually now if we combine these two results, what we'll get is absolute value of b minus c less than or equal to a, that's this bit here, which then is less than or equal to b plus c, which is this bit here. So that's as required, since that's the inequality that we've been asked to show.
Boom!
Alright, so that's part A done. So let's turn over to take a look at part B. So part B wanted us to prove this kind of inequality with our complex numbers. So it's the magnitude of mod z minus mod w less than or equal to mod of z plus or minus w, which is less than or equal to mod z plus mod w. And there's the word hence in the question, which kind of says link it up with what we've just shown in part A. And you can kind of see the kind of layout of this inequality is very similar to what we're trying to show. And actually, I think if I draw up just a simple argand plane, so if we say we've got our real and our imaginary and 0. Now if I just define some, complex number z and some other complex number w, then if we think about kind of our vectors, then this would be the vector for z with a magnitude of z. And this would be the vector for the complex number w, and the length of this line would be the magnitude of w. If I think specifically about the vector from w to z, so to get from w to z, I could go from w to o, o to z. So that's effectively kind of negative w z, or w minus z would be this vector. So the length of this line would be the magnitude of that. And we can kind of compare this triangle with the triangle that we've just dealt with in part A. And actually, if I kind of annotate over the kind of equivalent, so this would be the equivalent of A, B, and C in terms of the points. And this would be lowercase a, lowercase b, lowercase c in terms of the sides. And so if I now kind of go, well, from part A, what do we know? We know magnitude of b minus c is less than or equal to a, less than or equal to b plus c. And now what I'll do is I'll just insert these equivalents. So therefore we can say the magnitude of b, now b is mod z, minus c minus mod w. So the magnitude of that is less than or equal to a, which is mod, actually it should be, sorry, I've written that wrong, because we go negative w plus z, so that's actually z minus w, so that's the magnitude of that. So that's a is magnitude of z minus w, which is less than or equal to b, which is mod z, plus c, which is mod w. And you can see here we're pretty close. The only real difference between what I've just got here and what we're being asked to prove is the plus or minus. So we've got the minus, but I think that's fairly easily dealt with, because if you notice for our w, over here the w is inside an absolute value, and same deal here, we're kind of focused only on the magnitude, and it's only in here that whether w is positive or negative will have any impact. So if we let, or if we kind of replace w with negative w, so we just kind of think of essentially same magnitude, just opposite direction, then what we'd get is magnitude of mod z minus mod negative w less than or equal to mod z minus negative w less than or equal to mod z plus mod negative w. And these ones in here, because of these, the modulus kind of just go back to being w, because it's the same magnitude. So therefore mod of, or magnitude of mod z minus mod w less than or equal to mod z plus w less than or equal to mod z plus mod w. And so now we've got this result with our minus here and our plus, so therefore by combining, we can we can get this result. So we get magnitude of mod z minus mod w less than or equal to mod z plus or minus w, either way, less than or equal to mod z plus mod w as required. That's what we were required to prove.
Panic boom!
Alright, so I think that deals with part B. So maybe I'll turn over to think about part C, which was asking when is the magnitude of mod z minus mod w, when is that equal to mod of z plus w? So we're kind of looking at this part of the inequality, and we want to know when does equality hold, specifically with the plus bit. So if we kind of think about, well, this result came from this result, and this result we derived by looking at, I guess, this part of the cosine rule, like this kind of representation of our cosine rule, then this might be a sensible place to kind of think about, well, when would equality hold? So maybe what I'll do is I'll kind of rewrite this so that we can work with it. So let's say from A, we had noted that A squared is equal to B minus C squared plus 2BC, let's just make sure I get this right, B minus C squared plus 2BC 1 minus cos A. 1 minus cos A. And so if we want to maintain this equality, remember it was this bit here that got us to our inequality. So essentially if we want to keep equality, we just need this to be 0. And this will be 0 when either B is 0 or C is 0 or 1 minus cos A is 0. So we can kind of say equality when B is equal to 0 or C is equal to 0, or we say 1 minus cos A is equal to 0, or in other words cos A is equal to 1. Now when would cos A be equal to 1? Well, if we actually come back and look at our cos curve, when the angle is 0, we're at 1. So we could say angle A equals 0. And something that all of these have in common, and maybe I'll draw a diagram to show this, is that essentially we get collinearity. Or in other words, all of our dots end up just being on a straight line. So if we think about, if we come back and look at this triangle, ABC, now if B was 0, if that length was 0, essentially that means C has to come on to A, and so they're all on the same line. If C is 0, that means B comes onto A and they're all on the same line. Or if angle A is 0, then essentially B, this angle to be 0 means this point has to be coming here. So essentially we're kind of in this space where we've got, you know, 3 points all on the same line. You know, it would kind of look like A, B, C. And there's also the cases where, you know, the B is on top of A or the C is on top of A, and you kind of, either way, you're getting this straight line, you're getting collinearity. So I guess what we can say from there is, you know, remembering we kind of set B, what was B? We had B as B was the magnitude of Z and C was the magnitude of W. So if either of those complex numbers is 0, so therefore if the magnitude of Z is equal to 0, or the magnitude of W is equal to 0, or the angle just kind of, it's almost like you could call it angle A, which would mean kind of the argument, but I'll just call it angle A is equal to 0. Then what would we get? We'd kind of have, you know, A squared equals B minus C squared, or in other words, A is equal to square root of B minus C squared, which is equal to mod B minus C, and kind of inserting A. So A is, therefore you'd have mod of Z minus W equals magnitude of B, so magnitude of Z minus magnitude of W, which is kind of close but not exactly. So kind of we'll do the same technique that we used here where we replace W with negative W. So replace W with negative W, and what do we get? Maybe I'll just flip these. So we'd get mod of Z minus mod of negative W equal to Z minus negative W. So therefore magnitude of mod Z minus mod W equal to mod of Z plus W, which is the kind of condition we were interested in. So therefore this happens when, I guess we could say when Z and W, if we're kind of thinking about our complex numbers, are collinear. That's probably the simplest way to state it. When they're on the same line, basically, we'll get this equality.
Sonic boom!
All right, I think that's basically how you can tackle that part C. So that's the whole question done. So, I mean, an interesting question. You kind of take just your knowledge of a triangle and the cosine rule, and we've kind of taken that basic knowledge and kind of extended it to the complex number realm to then kind of get this result, which is a well-known result, a result you'd probably perhaps commit to memory, something you kind of want to be able to make use of in your, in your toolkit. And we've also thought about a certain situation where the inequality becomes equality. So hopefully that all made sense and you could follow along. If you found that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. All right, tick boom.